Good evening, good afternoon, good morning, depending on which time zone you're in. It is my pleasure to introduce Dr. Bob Watson as the speaker of this. I first met Bob, I think, at the second lead author meeting for the third assessment report for IPCC in Canberra at a dinner at Habiba Gatay and Ian Noble's house. And I know for sure the first time I worked with Bob was as part of the technical report on biodiversity and climate change for the IPCC. And I can clearly remember the meeting in Barbados when Bob showed up at plenary, but his luggage was lost somewhere, I think, in Russia. And so as the week went on, Bob just looked more and more wrinkled because his luggage never seemed to catch up with him as we went forward. Bob is Professor Emeritus in the School of Environmental Sciences at University of East Anglia and Director of Strategy at the Tyndall Center for Climate Change Research. He's been active in international assessments since the ozone depletion assessment. He was chair of the IPCC from 1997 to 2002, has worked on the Millennium Ecosystem Assessment, the Agricultural Assessment, and most recently, the Intergovernmental Policy Platform on Biodiversity and Ecosystem Services, and most recently, the Making Peace with Nature report, which he will talk about here. So with that, I will start the slides and turn it over to
Thank you, Jeff. Really appreciate it. Yes, what I'm going to talk to today is indeed making peace with nature, and you can make it bigger. Okay, perfect. Yeah, so this is the topic I'll talk about, the Climate-Biodiversity Pollution Emergencies. What do we know? What can we do? The next slide, please. This simply says we are facing a major challenge. We have four major global environmental issues that all threaten human well-being of both current and future generations. They're climate change, loss of biodiversity and the degradation of nature, land degradation, air and water pollution. And the key issues, all of these issues are interconnected and they affect each other, which I'll show in a few minutes. The next slide then talks about, let me talk about two quick examples of change so you can see the sort of things I'll be talking about in the talk. The first will be a slide showing the Earth is getting warmer and will continue to warm during your lifetime during human activities. And the second one shows that animals and plants are becoming extinct. Observations of extinction. This slide says, if you were born in the year 2000, that's at the left-hand side at the bottom, the Earth is already 0.75 degrees warmer than in pre-industrial time. By the time you're 20, now, it's already warmed 1.1 to 1.2. By the time you're 40, probably 1.7 to 2. By the time you're 60, 2.2 to 2.9. By the time you're 80, if you're lucky enough to get that old, 2.6 to 4.1. And if you reach the ripe old age of 100, it could be 2.9 to 5.3 Celsius warmer. That's with what I'll talk about later, current pledges under the Paris Agreement. But the basic point is the Earth has already warmed and it's going to warm much more over the future time. The only question is whether we'll be on the low emissions pathway at the bottom or the high emissions pathway at the top. The next slide shows you some extinctions. But this slide says extinctions are now occurring tens to hundreds of times, possibly even 1,000 times higher than natural evolution over the last 10 million years. The next slide does actually show extinctions. What you can see in green are mammals, and a few of those were even lost as early as between 1500 and 1600. Then some birds, especially on small islands, started to be lost between 1600 and 1700. But what you can see for fish, reptiles, birds, mammals, and amphibians, frogs, significant increase in the rate of extinction since 1900. The last 100, 120 years, basically. So we clearly are observing species are being lost already. The next slide. This simply shows you issues: climate change, land degradation, and loss of biodiversity. And you can't think about climate change without thinking about the loss of biodiversity or land degradation. They affect each other. Equally, you can't think about biodiversity without considering climate change and land degradation. All of these issues are intercoupled, but they also have a big effect on human well-being. They challenge food security, water security, human health. And so we now have to start to think about all of these issues together. Cannot think about climate change alone. We can't think of climate change or loss of biodiversity or land degradation as simply environmental issues. They affect human well-being. Therefore, they are economic issues, development issues, security issues, moral, ethical issues. Next slide. So, well, boy, why is human well-being threatened? What's actually happening? Well, climate change, loss of biodiversity, all of these issues, as I've just said, are not just environmental, economic. When climate change costs economic damage, biodiversity losses causes economic damage. They affect, as I said, food security, water security. So they're development issues. They're security issues. When you have climate change, land degradation or loss of biodiversity, quite often in some parts of the world, it leads to scarce resources, unsustainable weather conditions, and you get local conflict. So it's indeed a security issue. But there are also social issues. It's the industrialized world that effectively caused the problem, but it is largely, but not exclusively, poor people in developing countries that suffer. And so clearly social, moral and ethical issues. And it's really quite clear, if we want to eliminate hunger throughout the world, eliminate poverty throughout the world, make sure everyone has access to clean water and energy, everyone has a healthy life, a good quality of life, we must deal with climate change and loss of biodiversity. We no longer can think of them simply as environmental issues. The next slide. What will I focus on? Well, I'll talk about the current status of climate and biodiversity, what's causing them to change, what are the implications for change, why do we care, how can we limit the changes, and what do we need to do to address both issues simultaneously. The next slide. So this is the underlying reason. Why is the world changing? Well, in the last 50 years, the global economy has grown nearly fivefold. The world population has doubled. We now have over 7.5 billion people on this planet. International trade has grown tenfold. Well, what are the implications? Well, this increase in the number of people and the increase in their wealth means an ever-increasing demand for more energy, more food, more fiber, materials, and medicine. And the way we're producing our energy, food, fiber, materials, and is putting pressure on the environment. Now, while on average, the wealth of the world has gone up, it's still important to note we have an inequitable world. So while the average prosperity has doubled, we still have over 1 billion people being poor. We still have 700 million people go hungry every day. And in fact, in the last year and a half, during COVID, the number of hungry people has actually increased from 700 million to more like 850 million people. We clearly have an inequitable world. The next slide. I will now start to talk about climate change, then a little bit later I'll talk about biodiversity, but as you'll see, these issues are coupled as I go through the talk. Next slide, please. So what do we know about the Earth's climate? It's changing, and it'll change even more in the future, as I've already said. The Earth is already 1.2 degrees Celsius, 2 degrees Fahrenheit, warmer today than during the Industrial Revolution around the mid-1800s. Rainfall's changing. Some regions are getting wetter, the tropics and high latitudes, and some drier, the subtropics. What we will also see is more heavy rainfall and longer spells of light precipitation, meaning that we're going to be prone to more floods, and more droughts. And that's what the next one says. The extreme weather events are changing. More floods, more droughts, more heat waves, more frequent hurricanes and cyclones, or it's not obvious whether they're more severe. But we clearly are seeing extreme weather events changing in most parts of the world. Sea level is rising everywhere around the world, and the cryosphere, the ice, is melting. Arctic sea ice is melting, mountain glaciers are melting, the Greenland ice sheet, and parts of the West Antarctica, all melting. We're seeing major changes in the Earth's climate. The next slide. This simply shows on the left-hand side, it is a reconstruction of the Earth's global mean surface temperature over the last 2,000 years. And you see a wiggly line, and sort of grey, and then to the very right of it, you see observed. And what you can see is the observed change since 1850, last 150 years, is suddenly much higher than natural variability over the last 2,000 years. On the right-hand side, you see the modern record, 1850 to now. Over 30,000 land-based and sea-based, ocean-based observations. The black line, which you can see wiggling, where it's sort of orangey pink underneath, the black continuous wiggly line are the observations. And you can see in particular, since 1850, it's gone up. Slightly below that wiggly line, still in the orange area, is a continuous faint line. That's our theoretical simulations of the last 150 years. And as you can see, the model basically represents the observations quite well. And in that climate model, you have natural variability and you have human activity. Increases in greenhouse gases, increases in aerosols, changes in land albedo. If you look at the bottom in blue, there is a line. This is a climate model that only has natural variability, changes in solar activity, changes in volcanic activity. And as you can see, that line at the bottom does not simulate the wiggly observations above. We conclude from that, you cannot explain the observed changes in climate on natural variability. Human activities are the dominant cause of the observed change in the Earth's climate. The next slide is a global perspective. At the very top, on the left-hand side, is a global map of the observed changes to date. On the top, on the right-hand side, is a climate model that tries to simulate the observations as a function of latitude and longitude. What you see is it's a very good simulation. The land areas on average warm more than the oceans, slightly darker red, and the high latitudes, as you go to the northern hemisphere pole, the Arctic, they warm more than the equatorial region. And so the simulations are very good, even in 3 dimensions. We then look at the bottom and we say, well, what is likely to happen if we warm 1.5, 2, or 4 degrees Celsius? And let's just go all the way to the right-hand side, 4. What you see there, even more pronounced, the land areas are much redder than the oceans. So the land warms more than the ocean. And the high latitudes, especially to the Arctic, warm far more than the equatorial region. And in fact, in that model, you have a global mean surface temperature of 4. In the Arctic area, it's often going to be 7, 8, 9 degrees Celsius warmer. And even the land masses in Europe are going to be typically 4, 5, 6 degrees warmer. The next slide. This shows you precipitation. And effectively, all I'm going to say here is the darker green colours on the top 3 are where it rains more. And the yellow and brown is where it rains less. And you can see what the simulations show you is that effectively the equatorial region typically is green, and the mid and high latitudes are green. But effectively around the subtropics, including the Mediterranean area, we think it will get much drier. So the wet areas typically are getting wetter, and the dry areas are typically getting drier. Next slide. So why is the climate changing? And I've really already said this. We humans are increasing the atmospheric abundance of greenhouse gases. These warm the atmosphere. They act as a blanket around the world. The key gases are carbon dioxide. It's produced when we burn coal, oil, and gas to produce energy. It's also produced when we cut down our forests. We have methane and nitrous oxide, largely responsive to our agricultural practices. Methane comes from rice production. It comes from enteric fermentation in cattle, but also methane comes from leaky gas pipelines, and it's also naturally produced in wetlands. Nitrous oxide largely comes from our use of fertilizers. The next slide. This simply shows you what's our demand for energy been all the way back to 1800. But if you really focus from the right-hand side, the red line, from 1960 till today, in the last 50 years, our demand for energy and our use of energy has gone up by about 3 times in 50 years. And 75% of that has come from burning fossil fuels, the black line, the black wedge, the purple wedge, and the blue wedge. A small amount of energy has come from hydropower, from biofuels, and from renewable energy. But most of it comes from burning coal, oil, and gas. The next slide says we've changed our land. We've actually converted 3/4 of our ice-free land surface. We've converted it into roads, into cities, into monoculture agriculture, plantation forests. So we've significantly changed the land surface. And indeed, 1/4 of all of our greenhouse gases come from changing our land surface, especially from deforestation. We actually project that by 2050, only 10% of the ice-free land will be anywhere near natural, that 90% will be heavily or largely heavily modified. The next slide then shows greenhouse gas emissions. In blue, at the bottom is fossil fuel carbon dioxide. Above it is methane. Above that in orange is nitrous oxide, then some fluorinated gases, then carbon dioxide from land use change, predominantly at deforestation, as I've said. And above that, land use change can also have some small effects on methane and nitrous oxide. As you can see, we've had a continuous increase in greenhouse gas emissions since 1990 till today, about a 50–60% increase in emissions. The world, as I've already said, has already warmed 1 degree. Sea level rise is accelerating. And as I've already said, we're seeing more frequent and intense events, largely because of this increase in greenhouse gas emissions. The next slide. This is a complicated slide, but a couple of simple messages. The top left-hand figure, it actually has 5 lines in it. The top one is where you have very high emissions of greenhouse gases. Below it, you have high emissions, then medium emissions in yellow, and then we have low and very low. What actually happened, and all of these are plausible, depending on how we produce our energy in the future, how many people there are, what the demand for energy will be. If you're in the bottom 2 lines, the very low emissions, we can actually stabilize our temperature by 2100 between 1.5 and 2 degrees Celsius. These are the so-called Paris targets that I'll talk about in a minute. But if we've got the medium, high, or very high emissions, we're going to see changes potentially between almost 3 degrees up to almost 5 degrees Celsius. So indeed, depending on what the emissions are, will depend exactly on what the actual response of the climate system is. The next slide is also complicated, but it's some simple messages. Top one simply says, the more you put greenhouse gases into the atmosphere, the more the temperature rise. Blue is low, red is high. But also what happens is Arctic sea ice melts. So with the low emissions, the blue line, you don't get as much melting of the Arctic sea ice as you do in the red line. So the more we put greenhouse gases in the atmosphere, the more the Earth warms, the more we lose Arctic sea ice. But also, the more we put carbon dioxide in the atmosphere, it gets absorbed. 25% gets absorbed by the oceans. It becomes more acidic. You get carbonic acid form. So the more carbon dioxide that's absorbed by the oceans, the more acidic the oceans become, adverse effect on fisheries, and especially on coral structures. And lastly, but not least, the more the ocean warms, the more we see sea level. So all this is, while complicated, it simply says, as we change greenhouse gases, we change temperature, we change Arctic sea ice, we change ocean acidification, and we change sea level. The next slide. Okay, what are the major implications? Why do we change? When I used to live in England, I wanted a warmer climate. I really enjoyed hot days in summer. There weren't many of them, but I enjoyed them. Well, the trouble is, a warmer temperature around the world has adverse consequences. It affects food security. It affects water security. It affects human health. It displaces hundreds of millions of people due to sea level rise and inland flooding. And it can have adverse effects on nature, as I'll talk about in a minute. As far as human health, an increase in vector-borne diseases like malaria and dengue, an increase in waterborne diseases such as cholera, an increase in heat stress mortality, deaths from extreme weather events, and a lack of nutritious food. So in general, climate change has very adverse effects on most people in most parts of the world. Next slide. What do we need to do? Very straightforward. We need to stop using fossil fuels to produce our electricity and heat. We need to reduce our use of oil to power our cars. And effectively, we need to produce our energy from clean sources, solar, wind, and even nuclear. We need to use our energy much more efficiently. Electric cars, expensive today, but the costs will come down with mass production, better insulated houses, and more efficient appliances within the house. Efficient stoves, efficient refrigerators, efficient computers. We need to stop deforesting our land and reforest the lands that have been deforested. More sustainable agricultural practices that would reduce the emissions of nitrous oxide and methane. And we need to eliminate subsidies for fossil fuels and transportation, which encourage the use of fossil fuels and inhibit the use of clean energy. Next slide, please. Well, what's happening? Well, all governments agreed in Paris a couple of years ago, 2015, to limit human-induced global warming to less than 2 degrees Celsius and hopefully less, more like 1.5 degrees Celsius. All countries made pledges to reduce their emissions, but unfortunately their pledges are totally inadequate to meet these Paris targets. And today we're on a pathway to a 3 to 4 degree warmer climate, which would be disastrous for human well-being and nature. Governments will start to meet in Glasgow next week to agree on how to reduce greenhouse gas emissions and meet the Paris target. And if we want to meet the Paris target, the emissions of carbon dioxide must be reduced by about 50% relative to today by 2030, the next 8 years. And we also have to go to net zero emissions by mid-century. And we also need to reduce our emissions of methane, nitrous oxide, and the fluorinated gases. The next slide just shows you the same thing schematically. So in other words, to have a 50-50 chance of meeting the 1.5 degree target, 45% reduction relative to 1990 by 2030. If we can only reduce 25% by 2030, we're probably on a pathway to 2. Where are we? Well, with the current pledges, in 2030, the emissions are not going to be 25 or 45% lower today. They're probably going to be about 16% higher than today, although some recent pledges suggest they might be somewhat lower than today, but not very much. We are really on a pathway to a much warmer world. The next slide. It basically says the Paris Agreement is a good agreement. It's an excellent agreement. We need to be challenged. However, our pledges, as I've already said, are not effective. And in fact, we're likely to pass 1.5 by the early 2030s. And we're likely to pass the 2-degree threshold by 2050, 2060. The next slide, please. So let me now move to biodiversity and nature. Next slide. So what are we seeing? Well, we are destroying nature at an unprecedented rate. Species are becoming extinct. We think we have about 8 million animals and plants on Earth, and 1 million of those 8 million are threatened with extinction for a variety of reasons. The populations of most species are decreasing, as is their genetic diversity. We're destroying our forest, grasslands, mangrove swamps, coral reefs, and peatlands. I've already said that we have transformed most of the ice-free surface of the Earth. Next slide. What this shows is IUCN, International Union of Conservation of Nature, they look at how threatened are different species. So at the top is bony fish. At the bottom is cycads. If you see green, it means any green means that's the percentage of species that are not really threatened today. They're of least concern from an extinction standpoint. But if you go to the yellow, the orange, and the red, these are the percentage of species that are vulnerable, endangered, or critically endangered. And as you see, black, they're the ones that have already gone extinct. So if you go effectively to cycads at the bottom, you can actually see 60% of the color is either yellow, orange, or critically endangered red threatened. So 60% of cycads are in danger, endangered. If you go to bony fish at the top, it's more like about 10%, 8 to 10%. So in other words, different species are threatened to different degrees. The next slide, I've shown that. Next slide. And I've shown that. Next slide. So why are we destroying nature? I've already said, we're converting our natural ecosystems into agriculture, cities, roads. We're damming our rivers. We're overexploiting our plants and animals on both land and in the oceans. We've overfished most of the world's oceans. We're changing the Earth's climate. We're polluting our land, rivers, lakes, and oceans. And we're introducing alien species that become competitive with native species. The next slide just shows the same thing schematically. So for terrestrial and freshwater systems, the biggest threat is land use change, followed by direct exploitation, followed in yellow by climate change, followed by pollution in green, followed by invasive alien species in blue. In the marine systems, a very similar picture, but overfishing, exploitation is the biggest threat. Now, while climate change isn't the biggest threat today, it is potentially going to be the biggest threat in the coming decades if we don't control the Earth's climate. Next slide. So effectively, what are the major implications? Well, we're losing species, genetic variability, and smaller populations. We're losing the ability to produce food, clean water, energy, and medicines. We're reducing the ability of our ecosystems to regulate the climate, air and water pollution, pollination, floods, droughts, pests, and diseases. And we're losing some of the cultural value of biodiversity, the recreational value, the educational value, the sense of place. Next slide. And this is work that actually Jeff, who's moderating this session, is also responsible, along with his wife, Rachel Warren. And what this simply says is species have a climatically determined geographic range. And the question is, at what temperature, what percentage will lose that 50%. And so for insects, in a 1.5 degree warmer world, about 5% with an uncertainty will lose 50% of their climatically determined range. If we go to 4.5 degrees Celsius warming, about 68% of insects will lose half of their climatically determined geographic range. And then you see similar calculations for birds, mammals, and plants. One message here is every 0.5 degree warming increases the risk of species being moved or losing their climatically determined range. 1.5 to 2, look at the increase, 2 then up to 3, etc. The next slide is also work from Jeff, very recent work from Jeff and Rachel. And here what he's looking at is what temperature do you lose 80% of your climatic range? And so green is 1.5 degrees Celsius, yellow is 2 degrees Celsius, darker yellow, orange is 3.2 Celsius, and red is 4.5 degrees Celsius. And at the bottom is what percentage will lose 80% of their range in these different temperatures. And if you do lose 80% of your climatic range, you can consider those species critically endangered with a 50% likelihood of extinction in the next 10 to 100 years. And you can see in that middle part, just take beetles, a 4.5 degrees Celsius change, literally half of beetles may well lose 80% of their range, therefore significant at risk of extinction. This is absolutely superb work of Jeff and of Rachel, and he would explain this slide much better than me. Next slide. What can we do? Well, it's obvious. Stop transforming our land, have more sustainable agricultural and forestry practices, limit climate change and ocean acidification, reduce pollution, reduce invasive alien species, eliminate the subsidies for agriculture and forests, which actually lead to unsustainable practice and lead to encourage the use of fossil fuels, and acknowledge nature has economic and social value in our decision making. Next slide. So what do we need to do? We need to protect and restore life on Earth. We need to also address all of those 5 threats to biodiversity, as I've just said, and we need to have sustainable production and sustainable consumption of our goods and services. Next slide. Well, are governments doing anything about it? Yes. Most governments of the world agreed in Japan in 2010 to have 20 goals to conserve and restore biodiversity, so-called Aichi targets. Some progress was made on some of the targets, but none were fully met. And in some cases, we're in a worse situation today than we were 10 years ago. In particular, we have not reduced those 5 direct threats that I've talked to you about on biodiversity. Governments already met this last week virtually, and next year they're going to meet in China and agree on a new framework and a new set of targets to conserve and restore biodiversity. What we need is not just goals and targets, we need actions that are effective and monitorable. Next slide. So can we do anything about it? Yes. If we apply our human knowledge, our ingenuity, our technology, and if we cooperate with each other, we can transform our societies and economies, and we can secure a future that is sustainable. But it will require a fundamental change in the technological, economic, and social organization of society. We have to reconsider our worldviews, our norms, our values, and the governance structures. We need major shifts in investments and regulations, and we've got to overcome the inertia and opposition of vested interests. Some vested interests, like our unsustainable world, they're making a lot of money from fossil fuel exploitation, a lot of money from unsustainable agriculture, We have to overcome this opposition to a more sustainable world. Next slide. Well, as we all know, we've got COVID-19. About 75% of all new infectious diseases in humans have their origin in animals. This pandemic is not the first and it won't be the last. There are 700,000 potential viruses in animals and birds that could possibly pose a threat to human health. So what do we need to do? We need to reduce the risk of future pandemics, and we need to manage any future pandemic much, much better than we're managing this one. Well, how can we reduce the risk of a future pandemic? Reduce deforestation. Why? When we deforest in different parts of the world, we humans and our livestock come into contact with wild animals, and the wild animal can pass on a pathogen from the animal to us directly or indirectly through our livestock. So we need to reduce the interaction between us and our livestock with wild animals that have these potential diseases. We also need more hygienic wet markets. That is to say, there are wet markets all over the world, but a lot especially in Asia, where all different animals, birds and bats intermingle with each other, and these viruses are exchanged from one animal to another and then potentially onto humans. We have to manage this, and let's be quite honest, we have not managed this pandemic very well. A major success with the vaccinations, but really governments have not handled it well, and many in the public haven't handled it well. The refusal to wear masks, the refusal to get vaccinations. So we can all do a better job. We need to eliminate pandemics or minimize the risk, and we need to then act and manage them better if we get them. Next slide. So we need to transform our economic, financial and productive systems. We need to recognize the value of nature, recognize the value of natural capital in decision making. Gross domestic product is normally used to measure economic growth, but it measures unsustainable economic growth. We need to use what we call inclusive wealth. That's the combination of natural capital, built capital and human capital, a much better measure of whether economic growth is sustainable. We need to get rid of these harmful fossil fuel, fishing, transportation and mining subsidies, embrace a circular economy that is sustainable production and consumption, put a price on pollution, another word for internalizing externality, and we need to invest in a sustainable future, invest in a low carbon economy, invest in sustainable agriculture. The next slide says that we all need to work together. It's not just governments that have a role. We need to work together with international organizations, financial organizations, NGOs, the private sector, scientific organizations, and the public. We all have a role to play. Governments can set policies, stimulate sustainable practices in the business sector. Financial organizations, banks, pension funds, insurance companies should only be funding sustainable practices, not non-sustainable. What can we do as individuals? What can you do? Well, the first thing is vote for politicians that care about the future, that care about the environment, care about a sustainable future. Use your purchasing power to send a signal to the private sector. We want our goods and services sustainably produced. So send a signal. But beyond that, we can reduce our waste of food, reduce our waste of energy, reduce our waste of water, use energy, use water more efficiently. We can reconsider, should we have more vegetables and fruits in our diet? I'm not saying we should all become vegans or vegetarians. I'm not, I'll be honest. But I have a smaller amount of meat today and I have more vegetables and more fruits than I did a number of years ago. It's good for my health, and it's actually good for the environment. That, I think, is possibly the last slide, but next slide. Yes, that was the last slide. So if we continue as we are, business as usual, we will live in an unsustainable world, a world nowhere near as pleasant for our children and our grandchildren, but we can do something about it. All of us must act, and we can have a much more sustainable future. Thank you.
Thank you, Bob. That was very interesting. And now we have time for questions, which I'm waiting for Natalie to pass through from YouTube. So I suppose I'll go while we're waiting.
Yep.
What do you think is next?
Well, we have the two very big conventions coming up, as I said, the Climate Convention in Glasgow next week and the Biodiversity Convention in Kunming, China in the middle of next year. A lot of people say, am I optimistic? I'm an optimistic by nature, but I have to be rather honest, and I want to be proven wrong. I think we will see some progress in Glasgow next week or next 2 weeks, but I don't think anywhere near enough to put us on a pathway for the Paris targets of 1.5 to 2. China, the largest emitter of greenhouse gases in the world, India, the third largest greenhouse gas emitter in the world, both have said they can't promise to peak their emissions until close to 2030. They cannot in any way reduce their emissions significantly. So that means the first and third biggest emitters will continue at one level or another to actually increase their emissions, not decrease. I don't know if the United States can do what President Biden wants to do. And that is, he's promised a 50–60% reduction in greenhouse gas emissions in the US by 2030. But most Republican senators are opposed to this. So can he deliver? An interesting question. The other day, it was observed, or it was noted rather, that in 2009, 10, 11 years ago, the developed countries promised developing countries $100 billion a year to help developing countries mitigate and adapt to climate change. Today, we're around 80 billion, not 100. And an analysis has shown we probably won't meet the $100 billion until 2023. And many developing countries need financial assistance. So I think we'll see some progress, but I'm not at all obvious we'll see the progress we need. Boris Johnson's made a superb pledge, British government, a reduction in greenhouse gas emissions of 78% by 2035. But the Climate Change Committee, who oversees the government's approach to greenhouse gas emissions, has constantly said the UK is not on a pathway to meet the fourth emissions pledge or the fifth, let alone the sixth. We need far more demonstrable actions that can be monitored to be sure. So we need pledges. I applaud the pledge by the British government, but have they put in place the policies and the financing to meet those pledges?
Well, the Chancellor's latest budget would say no, but I am getting questions now. So how do we prioritize which species and or ecosystems we focus on saving?
I think it is wrong to focus on individual species. What we should indeed do is protect large ecosystems, especially those that are rich in biodiversity and rich in carbon. So by conserving and restoring the rich ecosystems, especially tropical forests, temperate forests, etc., it will have the biggest impact for both carbon and biodiversity. And by protecting those ecosystems, you protect individual species. It's all too clear that people want to protect the big charismatic species, the tiger, the rhinoceros, the elephant, etc. And yes, that's important. But some very humble little species, bats play an incredible role in ecosystems, and many other very humble species are really important to make sure that ecosystems are viable and function appropriately. And so I would say we should not just focus on individual species, we should focus on all ecosystems because they all have value, they all produce many goods and services for humans. But obviously, if we do have to prioritize some, I would tend to prioritize the one high in carbon, high in biodiversity. And indeed, there's a big move for more protected areas, more terrestrial protected areas, more marine protected areas. And this is good, but we will always have very important biodiversity outside of protected areas. And we need to make sure that we protect biodiversity that is both in a protected area and outside a protected area.
And do we need to incentivize the public to make a difference in their lives to tackle climate change?
I think if indeed our energy becomes more expensive in the near term, then I would say we should have some social safety nets to help the poorest in society if the energy bills go up. If we want houses to eliminate gas boilers and put in heat pumps, which are very effective. I don't have one in my house now, but in my previous house I had two, and boy are they effective. And then I do believe governments can incentivize the installation of heat pumps. If we need better insulation in our houses, in the attics, in the walls, or better two-level, three-level insulated windows, then yes, I think having the government help society become more efficient in the use of energy is very worthwhile. If they could sort of subsidize, incentivize the use of electric vehicles, that would also be helpful. So I think we can do a lot without incentives, but I do believe that in the short, near term, government can play a role to help society adapt to a low carbon economy and to adapt to climate change.
So a question is, tell us 3 things we can all start doing tomorrow.
Well, I don't know if you're going to vote tomorrow, although there is voting in many parts of America. As I've said, vote for politicians that care. Start looking to see whether the goods and services you buy are coming from reputable companies that care about sustainable development. Is the fish you're buying or is the food you're buying, is it sustainably produced? Send a message to the governments that you want, to the private sector, you want sustainably produced. And then absolutely stop wasting food. We all waste it to some degree. 30 to 40% of all food produced is wasted. It's wasted in restaurants. It's wasted in our refrigerators when we over-purchase. We can think about making sure we use our energy much more efficiently, turn the lights off when we leave a room, turn the television off when we leave the room. And of course, we can obviously, as I've already said, consider a more balanced diet. So while it's not one, but you put those things together, use mass transportation if you can, especially if you live in London. Do you really need a car? I lived in London for 5 years and commuted up to Norwich by train. Didn't have a car while I lived in England. Mass transportation worked very well. If I did want to go to the countryside, I'd rent a small car just for 1 or 2 days. And so think through how you can reduce your use of energy. Think through how you can actually reduce wastage.
And how much influence do you think one person has?
Everyone makes a difference. It all adds up. Obviously, any one person can say, well, if I waste a bit of energy, does it really matter? Well, there's 7.5 billion of us in the world today, or a bit more than 7.5 billion. If we all do a little bit, those little bits really add up. You know, so well, what's the old saying? If you save the pennies, the pounds will look after themselves. So every little bit makes a difference. And I mean, you know, I don't know how successful the youth movement will be, but look what's happened since Greta from Sweden started to sort of take a day off school on Fridays. It's sort of really got school children all over the world really starting to think about climate change. Some of the other youth movements really have got people thinking. To what degree are they affecting the politicians? I don't know yet, but it can only be good. So yeah, individuals can make a difference. The other thing that I found is if any one of us starts to be more sustainable, our friends, our family start to see we're being more sustainable, and they say, oh, maybe I can do the same. So on recycling, for example, once you told children that parents should recycle tin cans, paper, plastic bottles, if they saw their parents throwing in the normal rubbish, a tin can, plastic, paper, many children would say, Mum, Dad, we're meant to recycle that. So if we can teach our children that we shouldn't waste energy, turn the lights off, etc., that can also put pressure on parents, and our individual actions can influence the actions of other individuals. So individual action is very, very important.
And what's the most important thing a nation can do?
Well, I think it's fair. As I said in my talk, I would say that we have to look both simultaneously at climate change and loss of biodiversity. And therefore, from a climate change, we must reduce our emissions immediately. We must stop changing our nature, stop deforesting. Not an issue for England, I know. You only have 9% of your land forest, the lowest in all of Europe, quite embarrassing. So clearly, if I had to pick the area, number one, reduce our emissions immediately. Two, because the climate is already changing and will continue to change, we've got to start to adapt, and we've got to start to be prepared for an even warmer world of 1.5, 2. And I would say we need to plan for a 3-degree world in case we can't limit climate change to 1.5 to 2. And so there's no question, if addressing climate change addresses climate, it addresses biodiversity, and it actually and it helps on food and water security. And the first thing I do is change the economic incentives, get rid of fossil fuel subsidies, and start effectively to invest in a low carbon economy.
Some comments have come through and they're related, so I'll just put them together. People say to me it is on China to do more. I don't agree, but never know how to respond. And if another person wrote, if we want to help China to change, we have to change our consumerism.
Very good point. I mean, China 30 years ago was really a developing country, quite poor. You know, more than 1 billion people, really poor. India today has 1 billion people, really poor. I mean, really in poverty. Why has China's emissions gone up so much? Why are they the number one emitter in the world today? Well, one, their own economy has grown tremendously. And so they've needed more and more energy, most of it produced from fossil fuel. But the other reason is they're supplying the goods and services that we use in America, that you use in England, others use in Europe. So a percentage of their emissions, I'm not sure the exact number, maybe 20, 30% of our emissions, are not for domestic use. They're actually for producing the goods that are being used in America, in Europe, in England, given England is no longer part of Europe, in a true sense of the word, the European Commission, European Union. So you're right. If we can reduce our consumerism, actually, to some degree, it will actually reduce the emissions from China. Now, what we have to realize is an ethical issue here, and that is, it's the industrialized world, the US, Europe, who've actually put most of the greenhouse gases into the atmosphere. It's only recently that China and India have become the big emitters, but still the per capita emissions in China are still well below America, becoming comparable to Europe, but the per capita in India are still well below Europe and North America. And so even though their absolute emissions are high because they have very large populations, their per capita is still lower. And so this has, so we have to think through the ethical and moral implications of historical emissions and also per capita emissions. So to me, what that means is the industrialized world, which on average is richer, has more technological capability, has really good knowledge. We need to take the lead. All countries need to reduce their emissions, all, including the developing. But we in the industrialized world do have a responsibility to work with developing countries with financial aid and technological cooperation.
And probably the last question given time is, what key actions do you hope come out of COP26?
I mean, if I was dreaming and daydreaming, that actually the pledges supported by monitorable actions would actually put us on a pathway to 1.5 to 2 degrees Celsius. That is to say, there would be an agreement to reduce greenhouse gas emissions by 2030 by at least 25% and hopefully 50%, and they would actually show how they would do it. That's if I'm daydreaming. That would be my dream. That's what I would love to see. I think it'll be unlikely to see it. The question is, how far can we go to reach my dream?
It seems to me that Paris caught the scientists off guard in terms of coming in at 1.5 degrees and us not be really knowing what that would be until afterwards. So do you see maybe something like that would come out of COP26?
Say that one again, Jeff. I apologize. I'm not quite sure I understand what you were asking.
Well, a lot of scientists that I know were sort of caught slightly off guard that the governments actually came in at 1.5 degrees.
Yeah, okay.
And so we then had to look really hard at the models and things to see what would happen at 1.5 degrees. The SR 1.5 report. Is there an equivalent for COP26?
No, I actually think there'll be no change in what the goals of Paris are. That is to say, I don't think the governments will change the target of less than 2 and preferably 1.5. And the reason is, if let's say they were to say, 1.5 is not achievable, so let's soften it and let's say 2 is our new target, not less than 2. I think it would unravel the whole negotiations. And then, in 5 years' time, well, maybe it should be 2.5. So I think a really hard stretch target is still needed. I mean, when they went into Paris, I think most people expected the target to be 2. But small island developing countries and actually the biodiversity community said, and based on a lot of your work, Jeff and Rachel, said, even 1.5 is a real problem for biodiversity. And by the time you get to 2, it's a real issue, not only for biodiversity, but food security, etc. So originally, I think the target was more likely to be 1.5, but small island states and some of the NGOs pushed and pushed and pushed. And that's why you see the target being less than 2 and preferably 1.5. And I don't think it'll change. I think the question is, how close can we get to those targets and what actions do we need?
All right, well, with that, I believe we are out of time. So thank you very much, Bob, for your inspiring talk.
Well, thank you, Jeff, for moderating it, and keep doing that incredible research with Rachel.
All right, thank you.